Welcome to this rather special event in the Oxford Mathematics Public Lecture Series in collaboration with Faber members to mark the publication of a play, I Is a Strange Loop, that I've been working on in collaboration with actress Victoria Gould. We're going to be joined by Simon McBurney, the founder of Complicité, for a three-way conversation between all of us. But before that, we're going to join the audience at the Oxford Playhouse for a screening of a performance of I Is a Strange Loop.
Y.
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 1.
1.
1.
Y equals 1.
Y equals 1.
Y equals 1.
Multiply by y.
Y squared equals y.
Take 1.
Y squared minus 1 equals y minus 1.
Factorize.
Y minus 1 times y plus 1 equals y minus 1.
Cancel.
Y plus 1 equals 1.
Therefore, y equals...
Y equals 0.
Ha! Y doesn't exist. Identify.
Y.
Quantify.
1.
Y equals 1.
Y equals 1.
Multiply by y.
Y squared equals y.
Take 1.
Y squared minus 1 equals y minus 1.
Factorize.
Y minus 1 times y plus 1 equals y minus 1.
Cancel.
Y plus 1 equals 1.
Therefore, y equals...
0.
Therefore, y doesn't exist.
You can't divide by 0.
Do.
Identify.
X.
Quantify.
1. Unique.
So, x equals 1.
X equals 1.
Multiply by yourself.
X squared equals x.
Differentiate with respect to yourself.
Oh, 2x equals 1.
Therefore, x equals...
X equals a half. Ha! Oh! Oh!
Square yourself.
X equals a quarter.
Cube yourself.
X equals 1/64.
Raise yourself to the power of...
No!
of 0.
X equals 1. X equals 1. X equals 1. X equals 1? But you can't differentiate with respect to a constant. Identify the coordinates of your origin.
There.
There? And the conjectural coordinates when your velocity vector hits 0?
Out.
Out?
Out.
Oh, yes, out. Out.
No. Out!
Out! Define your terms.
Oh, way out! This can't be all there is. A long line of rooms.
Rooms.
Yes, rooms.
You've just created a singularity at the side of my cube. Oh. there exists another room.
And another room, and another one, and another one. They're all the same. It's room after room after room.
Oh, an infinite number of rooms.
No, I didn't say it was infinite. I said it's room after room after room.
No, I think I can prove that it's infinite.
Really? How?
Induction.
Induction.
Let Pn be the inductive hypothesis that there are n rooms in this line. Let n equal 1. My room exists, therefore P1 is true. Well, that's the base step. Now, suppose that Pn is true. Well, I exit to find another room isomorphic to the nth room. Therefore, Pn plus 1 is true. Well, that's the inductive step. Well, now apply the second order axiom of inductive logic for the natural numbers to prove that Pn is true for all n. Therefore, the line of rooms is infinite. Oh, quod erat demonstrandum.
Yes, but if it's infinite, then there's no way out.
Well, there is no out.
No, there must be something else. This can't be all there is.
Well, a manifold needs no ambient space to exist. Just a room after room after room after room after room after room after room. It's an x squared plus y squared plus z squared equals r squared.
It's an orange.
Oh, an orange sphere.
Yes, an orange sphere.
Oh, the orange sphere is establishing a functional relationship with my nose. Oh. A segment of the orange sphere has become embedded as a subset of y. Redefine the origin of your orange sphere using the following equation. X minus 14 squared plus y minus 14 squared plus z plus 2 squared equals r squared. X minus 14 squared plus y minus 14 squared plus z plus 2 squared equals r squared. One. Another one.
1, 2, 3 lots.
Yes. Oh, The origin of the orange sphere should follow the following path, defined by the equation y equals z minus g divided by 2z squared, where g is the acceleration towards the floor. Ha! 1. Oh. 1. 1. Oh. 1. 2. Oh. 1, 2. 1, 2. Oh. 1, 2. 1, 2. Oh. Another one.
1, 2, 3, lots. Yes.
The origin of the orange sphere should follow the following path, defined by the equation x equals e to the minus t sine t, y equals e to the minus t cos t, and z equals 1 over t, where t is a parameter running from 1 to infinity.
That's not physically possible.
Well, it's a well-defined function.
It's not physically possible.
An approximation would be acceptable. The orange sphere, conjecturally. Well, a surprisingly small epsilon. 1. 1. 1. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 3. Another one.
1, 2, 3. No.
An integer divider. A multiplication inverter. A disconnected space creator.
A knife.
Knife?
Knife.
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 Knife. Huh. Knife. Knife. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
What are you doing?
I'm physicalizing number. Well, I've cut this orange sphere into a half with your knife, and now I have 1, 2, 3, 4 pieces of orange sphere. If I cut this piece in half again with your knife, then I will have 1, 2, 3, 4, 5 pieces of orange sphere. If I apply the same inductive reasoning that proved the line of rooms was infinite, then after infinitely many cuts, I'm going to have infinitely many pieces of orange sphere.
I'm afraid that's not physically possible.
Well, it's going to take me some time.
It would take you more than some time.
Well, how much time?
It would take you an infinite amount of time.
That is a long time.
Especially towards the end. You would have to spend the rest of time cutting that orange sphere.
What if I cut one orange sphere into a half in 8 seconds, and then I cut a half into a half in 4 seconds, and then I cut a quarter into a half in 2 seconds, and then an eighth into a half in 1 second, and a 16th into a half in a half second, and 1/32th into a half in a quarter of a second, and then 1 second.
It's all right. I can see the pattern.
Good, because you see, after infinitely many cuts, I will have infinitely many pieces of orange sphere, but it's not going to take me an infinite amount of time. Take me the sum from n equals -3 to infinity of 2 to the minus n. I can create infinity in 16 seconds.
That's a lovely idea.
Thank you.
I'm afraid you won't be able to make it work in reality.
Why not?
Well, you'd have to keep cutting faster and faster, and eventually you'd be cutting so fast you'd hit the speed of light, and nothing travels faster than the speed of light because speed is finite.
No, I can do it. I can.
And space, too. You can't keep dividing space. At some point, you'll hit the atom. Split that, and you'll blow the whole place sky high.
No, it's going to work. The maths makes perfect sense.
Do it, then.
Really?
Do it. I'll time you. Cut that orange into infinitely many pieces in 16 seconds.
I will.
And I shall time you. Gosh. I'm going to enjoy this. Infinity created before my very eyes. Your hand moving faster than the speed of light. My knife becoming so sharp it'll be capable of splitting the atom. Gosh, I'd better put on my safety goggles. Right. Fully prepared. What can go wrong? Are you ready?
Yes.
Pick up the knife. 1 orange. 16 seconds to create infinity. Ready? Cut! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, stop! Stop cutting. Put down the knife. Step away from the orange. So you have created infinity.
I didn't realise that equations were quite so sticky.
But you have created infinity.
Well...
Nearly.
How
far did you get on your way to creating infinity?
1, 2, 3, 4, 5, 6, 7.
7?
Well, I just need more practice.
Especially towards the end.
No, I don't understand it. I can infinitely divide numbers up and add them all up. And why can't I do that to the orange sphere?
Because the orange is real, but infinity isn't. Infinity only exists in the imagination, not in real, true life.
It does?
No, it doesn't.
Does?
It doesn't.
It does?
Doesn't.
Does?
Doesn't.
Does?
Doesn't.
Does?
Doesn't.
Does?
Doesn't.
Well, if
Doesn't.
infinity doesn't exist, what's the biggest number then?
Oh, the biggest number is 73,000,012.
What about 73,000,013?
Gosh, I was very close.
What? No. Numbers don't run out. Infinity does exist.
Oh. Come and sit down. We need to have a little chat. Come on. Numbers are just in your mind.
Well, I mean...
In your life, you only have a finite amount of time. So there is only a finite number of numbers you will ever need. So for you, and for me, there will be a biggest number. At some point in your life, you'll think of a number, and after that, you'll never think of a bigger one, because you'll die before you get the chance.
Die?
Yes, die. Your cells won't reproduce anymore. The telomeres in your chromosomes will get shorter and shorter until they're all used up. The last number. No more +1. The end of the line.
Yeah, but a line has the potential to go on forever.
Ah, potential. That's a marvelous idea. Teeming with possibilities. And forever. I think that's my favorite idea of all. They all lived happily ever after. No, I'm afraid you can prove to me that infinity's a lovely, consistent idea, but you'll never be able to show it to me. Take this space. It's all finite lines. It starts here, and it ends here. You're born there, and you die there. And this line of rooms, too, it has a beginning and an end. It's all finite.
But there is infinity in this cube.
Really?
You promise you won't tell anybody?
All right.
Just before you arrived, I discovered infinity hiding in this cube.
Really? Where?
from there to there.
That's a finite line.
Oh, no, not so, not so. If the side of my cube has length y...
Oh, that's like me.
And the diagonal across the cube has length x...
That's you.
Then x is bigger than y by a factor of the square root of 2. And that's an irrational relationship.
What do you mean it's an irrational relationship? I'm not irrational. Who are you calling irrational? There's nothing irrational about me.
No. X and Y are incompatible.
What do you mean how can we be incompatible? We've literally just met each
No.
other.
If you write the square root of 2 as a decimal, then it goes on to infinity, never repeating itself.
So, you won't be able to show it to me.
No, I can. It starts 1.4. At 1, 4.
You don't mind if I make myself comfortable, do you, while you do that?
Yes.
Got a feeling we may be here for some time.
Yeah, right.
You will make sure, won't you, that each step is 10 times smaller than the one before?
Yes, I know.
And I know you know, but just so you know, your next 3 steps should be the size of a pollen grain, followed by a bacterium, followed by a virus on a bacterium.
2, 1, 3.
Very good, you've got to 6 decimal places. Only an infinity to go. And you do know, don't you, that after the 32nd decimal place, your steps should be no bigger than a photon of light.
5, 6, 2.
You're now about the size of a single coil of DNA.
Right.
Of course, you won't be able to measure anything after the 34th decimal place because the Planck constant is the smallest ruler that could possibly exist. You are going to have trouble showing me, aren't you? Never mind. Have a sandwich. Well, as much fun as this has all been, I'm afraid we're going to have to admit, aren't we, that that infinity is also in the mind.
But what about time? That goes on forever.
No. Time doesn't go on forever. Time has an end. That end even has a name. The heat death of the universe. The second law of thermodynamics states that if the universe lasts for a sufficient time, it will asymptotically approach a state where it has diminished to a position of no free thermodynamic energy and is therefore no longer capable of supporting processes that consume energy, including computation and life.
Shit.
Oblivion.
Oh, that infinity looks a bit bleak, especially towards the end. Oh, the line of rooms. I proved that was infinite for you.
Oh, that proof of yours. You do know there was something not quite right about it, don't you?
Not quite right. What?
Just because I've been through lots of rooms that don't contain out doesn't mean out isn't in the next room. See, take this coin.
Oh, you've projected the sphere into 2 dimensions.
Yeah, well, it has 2 sides. It has a head side and a tail side. Now, every time I toss this coin like this, it's equally likely to land tail side as land head side. Heads. Every time I go into a room, it could contain out. Just as each time I toss this coin, it could land tail side. It doesn't matter how many times I've tossed it and got heads. Doesn't mean I won't get tails on the next throw. Your proof implies that this coin always lands heads. Even if I tossed 10 heads in a row, there's still a 50-50 chance I'll get tails on the next throw.
How many rooms have you been through?
73,012,000.
And it always lands heads.
Yes.
An unbroken sequence. of 73,000,012 heads?
Yes.
Ha! Are you sure your equation hasn't lost its tail? I mean, perhaps it's the same on both sides. Same.
The same.
Just the same.
That's it. Your proof assumes all the rooms are the same.
Well, yes, you said they're all the same, just room after room after room.
But they're not all the same.
Really?
The rooms look the same, but what they contain is different. Where do you think I got all those oranges?
Well, I thought you blew up the singularity at 0.
Nope, I found them in some of the rooms I went into. There are other fruits out there too. There's a pomegranate. Oh, a kumquat. A lemon.
Oh! It's an x squared divided by a squared plus y squared divided by b squared plus z squared divided by c squared equals r squared. An ellipsoid.
Here's some celluloid. Oh, a vuvuzela. A bagel.
Oh, r1 minus the square root of x squared plus y squared all squared plus z squared equals r2 squared. It's a genus 1 surface.
Oh, here's a slinky. Oh, and a folding bicycle.
Gosh.
Ah, a book.
Oh, a cuboid. Oh, a cuboid. Did you see that? Look, it's decomposing itself into a foliation of parallel submanifolds. Oh, with a singularity running right down through the middle.
This room wasn't empty, was it?
Well, it was before you brought all your things in here.
No, you were in here. This is the first time I've come into a room and found another person in there. Have you ever met another person?
Person?
Like me.
Oh, another variable? No, I thought I was unique.
Fascinating. So if a room can contain you, it can contain out. What's behind that door there?
Oh, I don't know. I've never looked.
You've never looked?
No.
Oh, of course you've never looked. Why would you ever have looked?
But I thought this was all there was.
So, out might be on the other side of that door.
Are you out? Oh! How did it land?
Heads again.
What?
Heads again.
Oh, a hexagon.
I said heads again!
So it is infinite. What's that?
It's a ball of string. I found it in the next room.
Oh.
And this ball of string proves that your proof doesn't work. Because if a room can contain a ball of string, it can contain out. Stop moving about. You can't prove to me that it's infinite, can you?
No.
Exactly. Put those things down and take this. Carefully. This line of rooms is not infinite. Infinity doesn't exist. This line of rooms has an end. It has an exit. It has out. And I am going to find it. And when I do find it, I am going to prove it to you.
Oh, how?
With string.
String?
Stand there. Hold that. carefully in both hands and don't move. I'm going to take this end of the string and I'm going to walk into the next room and into the next room and into the room after that, if necessary. And I'm going to keep on walking in a straight line through room after room after room until I find out. And when I find it, I'm going to pull on the string 3 times like this to prove to you that I have found it.
Well, how long is your ball of string?
It's as long as I need it to be.
You're going to need an infinite ball of string.
We'll see.
How many are there of you?
1.
No.
Y equals 1.
No, the Y is that way.
Y is that way.
No, Y said she was going to go in a straight line that way.
I did go in a straight line that way.
Well, how did you come from over there then?
It's all joined up.
Oh, it's a loop.
There is no out.
Oh, it's not infinite. We were both wrong.
We were both wrong. Oh dear. Oh dear, dear, dear. How very disappointing. I'm so very tired, you see. I've travelled such a long way. I've collected all this stuff. I've kept everything I've come across. I've carried all this. And for what? What's the use of it all? What has it brought me? What does it all mean?
But you've got everything.
I've got nothing. Nothing. I'm just stuck here in this line of rooms.
You've got me?
Yes.
X squared plus y squared equals 1?
Codependent variables.
Yes. Yes. When x was 1, y was 0.
And when y was 1, x was 0. But
now x equals y. Oh, x squared plus y squared equals 1. Oh, x and y are both half the square root of 2.
That's very nice, dear.
Your hands. Your face.
I was away for a very long time.
But you only just left.
I've been travelling for many, many, many years. And now I'm approaching my singularity.
What, a singularity? But a singularity is a point which isn't defined. It doesn't exist. No. We've only just started.
X times y equals 1.
You inverted the circle. Is that a way out?
No. But as y tends towards 0...
X tends to infinity, so I get my infinity back.
Yes, I suppose you do, but I'm afraid you lose me in the process.
I don't want that sort of infinity.
I'm afraid that's reality. There's not much we can do about reality.
I can resolve your singularity.
No, you can't. But you can tell me about your out.
My out? My out. A place where numbers go on forever. Parallel lines meet. You can create new geometries, new numbers.
Like the square root of 2.
Yes. Like the square root of 2. X and Y are incompatible. The sequence of diminishing squares never terminates.
Can you make a new number?
A new number? A new number? Create a new number.
You don't mind if I just close my eyes for a moment, dear, do you, while you do that?
1, 2, 3, 4, 5, 6, 7. Nothing new there. -1, -2, -3. A half, quarter, an eighth, a 16th, 1/32. The square root of 2. The circumference of a circle. Nothing. Why? I've got nothing. Why? No new numbers. Why aren't you listening to me? Why? What's happened to you? Y equals 1. Y equals 1. Y equals 1. Y squared equals y. Y squared minus 1 equals y minus 1. Y minus 1 times y plus 1 equals y minus 1. Y plus 1 equals 1. Therefore, y equals 0. Nothing. No, that can't be all there is. There must be something else. The square root of nothing. No, that's nothing. The square root of 1. That's 1. Minus 1. The square root of minus 1. No, there isn't a number which, when you square it, equals minus 1. Take the square root of minus 1. Imagine it. X squared equals minus 1. Well, a plus times plus is plus, and a minus times minus is also plus. Oh, so the square root of minus 1 would be a new number.
Shh.
Well, it's self-consistent, non-contradictory.
Shut up.
The square root of minus 1. It's a new number.
Stop it.
A new world. A new direction. Oh, I've done it. I found out. I did it. I created it out.
Stop it.
Oh, you're alive. Oh, it's worked.
No, I'm dead.
No, you're alive. Oh.
No, I'm dead.
But you're not dead.
I am dead. I died.
Yes, and then I've saved you with my new number.
You didn't save me. You can't save someone who's dead.
But how come you're alive?
I'm not alive. I'm dead.
But I don't understand.
It's very important that the play ends with my death. It symbolizes the nothing that awaits us all at the heat death of the universe.
So you're dead.
Yes, I'm dead.
But you're alive.
Of course I'm alive.
No, I still don't understand. How can you be dead and alive at the same time?
Because I was acting! Everyone here was complicit in the act of imagining I was dead. We were telling a story.
Have we finished the story?
Yes!
Oh.
Well, no, we're still here, aren't we?
But you're not going to die.
No.
Oh.
Well, yes, that's the whole point. But not now, I hope.
So that was just a theoretical death?
No, it was a theatrical death.
Oh, so none of this is real?
No. Well, yes, I am real, I hope.
And I am real, aren't I?
I don't know.
Well, you really are why?
No. Olive.
Olive? Y equals olive?
Yeah.
But olive equals 1, multiplied by the size by olive. Olive squared equals olive squared minus 1 equals olive minus 1 in factorized. And well, I suppose it still does work.
Oh, good. We're in a real space.
Right.
With all these lovely real people.
People?
Yeah, we have an audience.
Oh, more variables! Oh, what are they looking at?
Well, they're looking at you and me and our imaginary world.
Where nothing is real.
Yes.
Oh.
Well, no, I mean, that bag is a real bag.
Yes.
These trousers are real trousers.
Yes, and my room, that's real.
No!
What?
It hasn't even got real doors.
Oh.
The cube is real, but it only exists because it's part of a theatre set that we had specially built.
Yes, but if you go through the imaginary doors, then there are more cubes that way, and more cubes that way.
Oh, no, there's nothing else. This is it. This is all there is. This is our entire set, is this one cube.
Oh.
Actually, that's not quite true because somewhere we've got a model that our designer made us have specially built so that we could see what the cube was going to look like when we built it for real.
Oh. Oh. So that's my cube.
Yeah, no. Yes, it's a model of your cube.
Right.
Actually, in here, there are also some other models, I think. Oh, yes, look. Here's you. Wobbly head. And here's me. Here's you in your cube. And here's me coming into the cube. Y equals 1. Multiply by y. Y squared equals y. Take 1. Y squared minus 1 equals y minus 1. Factorize.
I don't sound like that.
You do sometimes sound a bit like that, actually. Sometimes, yeah, you do. You do a bit sometimes. Anyway, so this model helps us to tell the story.
And the story is real?
No. Well, yes. Yes, it's a real story, but the story's not real. We made it up.
When I made myself up?
Yes. You're in the script. We're both in the script.
Script?
Which ends with my death.
Oh. So am I in the script now?
No, we finished the script. Oh. We're off script.
So what are we doing now?
I don't know.
Oh.
In fact, I'm not entirely sure I have any idea what's real and what's not real anymore, at all.
Oh, the script was real?
Well, yes. Yeah, the script was real, but I think the ideas in the script were all too real. And maybe I'm starting to think that the mathematics in the story was the most real thing of all.
So infinity is real?
Yeah.
I knew it!
Well, no. It's a real idea, but it's not real. You can't show it to me.
So what is real?
What is real? Okay. The quest for meaning, that is real. That's real. The desire to subvert the finite. The need for happy ever after.
You mean the search for out?
Yes, I suppose so.
Yes, because you know when you were dying and you were going to leave me on my own in here with my infinity, and
Yeah.
I thought I was going to miss you rather a lot. I had just found you an out.
Really?
Yes, I created a new number. Well, you encouraged me, and then I imagined it, and then there it was, a new direction.
But how is that out?
Well, I thought you could climb up and out.
Well, how could I climb out there?
Well, I thought... Oh, I hadn't got to that bit yet. Well, maybe the model will help me find a solution. Yes, maybe the model will help me to find a solution. This Y, where's X gone? Where's X? Here's X, yes. Here I am, we're both in here. So, how could I get up there? Well, I don't know. I just got as far as imagining a new number. I hadn't really worked out a way for you to get out yet. I mean, well, maybe there'd be something, or maybe there's something more in the box. Yes, in the box. Maybe something in the box. A script. Oh! Look! Look what I found! Oh! You could climb out on these. Oh, you are so very clever, X. Oh, you are. Yes, thank you very much, X.
I don't sound anything like that at all.
Well, you do sound like that a bit. Yes, so you see, I thought that you could climb up now. I created a new direction with my new number, and now you could climb up and out. Oh, thank you very much, X. Yes, you're right. I can climb up to the new direction, and then your new number has found me out. Well, I think maybe this time I would come with you. Well, maybe it would be infinite in that direction. Oh, and then we would both be out. Yes.
Come on, then.
Okay. That's real. It's real. I'm coming. Why? Why? I'm oscillating.
Oscillating?
It's very high.
Oh, that's fear. Entirely natural, given the potential risk.
Risk?
Well, what you're attempting to do is incredibly dangerous.
I'm stuck. I can't move.
That's paralysis. Fear in its most acute state. What you need is a good dose of induction.
Induction?
Induction. Let Pn be the statement you can climb n rungs of the ladder. Now, you've already got onto the first rung, so that's the base step proved.
Right.
And then, from the nth rung, it's a simple step up onto the n plus 1th rung.
Oh, simple for you, maybe. Oh, that was quite simple.
Good. That's the inductive step.
Right.
Now, apply the second order axiom for inductive logic, and you'll find you can climb as high as you like.
Really? Oh, induction. Right. Induction. Oh, it's working. It's working. Why? Induction. Oh, I'm coming. Why? Oh, to infinity. Oh, nearly there. Why? Induction's doing it. Yes, I'm nearly there. Oh, one more.
Keep climbing.
What the factorial? How the factorial did you? What the factorial is that?
It's a trick.
A trick?
Yes, a trick. It's a trapdoor.
A trapdoor?
Yes, a trapdoor. It's a trick trapdoor.
A trick trapdoor?
Yes, a trick trapdoor.
No, I don't understand. How did you go up there? Now you're coming from down there.
Theatrically. You want to step inside?
Well, is it safe?
Is it safe? Yes, it's safe.
Okay. Oh, it's very dark down here. Is that a spade? Oh, and there's a skull. Is this a digger I see before me? Oh, can I come out? No, it's horrible. Horrible. Oh.
So, you see, it's a theatrical trick.
No, I still don't understand. You went up there. You go.
I didn't really climb through a hole in the ceiling.
Really?
No, what I did was, I climbed up this ladder here, and then I climbed down the back of the ladder behind the black cloth. See?
Oh, really?
Yeah. And then I just walked off the stage.
Oh, really? Out?
No, I just walked off into the wings.
Wings? Our space can fly?
Oh, it's a theatrical term.
Oh.
I just walked off stage, into the wings, like this, and I squirreled round the back.
Round the back?
Yeah, round the back. There's a way round the back.
Really?
You could go and have a look. It's quite safe.
Okay.
Quite safe. I'll talk you through it.
Round
the back. So
what
you
do I do?
step off the set. There you go. And walk across the stage.
Right.
Behind the wings.
Oh.
There we go. You'll be fine.
Oh.
Bit dark. You'll be okay. And
can't
you'll
see
find
anything.
if you turn left, you can just squirrel right round the back.
Oh, there's another variable. Oh.
That's the stage manager. It's all right.
Oh, I can't see anything. It's just blackness and... Oh, there's a way around.
Yep.
Do I do the squirrel?
Yep, you do the
Okay.
squirrel all the way around the back.
Right. Oh,
Keep going.
I can see a blue light on the other side.
Yeah.
There's a light at the end of the tunnel.
That's the backstage light.
Oh, it's all symmetrical.
Yep.
Oh, it's a loop.
Yeah.
Oh.
So now you should find your waiting in the wings stage right.
Oh.
And if you keep walking, come onto the set, you'll find you've made an entrance.
Oh, look. So you didn't go all the way around the universe. You just did the squirrel round the back. Is it invertible, the function?
Yes, you can go the other way. It's going to go all the way around the back again. Oh, when he comes back in, he's going to make another entrance. Shall we give him a little round of applause when he comes in, just so he knows?
Oh, it is invertible. Again?
I think he really enjoyed that. Shall we indulge him just once more?
Again?
No, don't milk it.
Milk it?
Never mind. So that's how we suggested that our space was looped in two directions, you see?
Oh, so my new number didn't find you out?
No, we'd just be on another surface that was looped in two directions. So, for instance, we could be on the surface of a gigantic orange. So it would be looped in that direction and in that direction as well.
Right, yes.
Yeah.
Or you could be on the genus 1 surface you brought in. You know, the R1 minus the square root of x squared plus y squared all squared plus z squared equals R2 squared.
The bagel.
You had a name for that. What did you call it?
Yeah, the bagel.
Yes, the bagel. Where's the bagel?
I ate it.
You ate it?
I was hungry.
Oh, you ate the universe?
It's just a prop.
Well, quite an important prop. What's a prop?
What's a prop? Well, a prop is something that we use in theatre, either as itself or pretending to be something else. We use it to help us tell the story. It's part of the power of theatre. The theatre is the set of all possible self-consistent structures. See, in theatre, we can suggest, and by suggesting, we can make something seem real. See? Listen. Can this cockpit hold the vasty fields of France? Or may we cram within this wooden cube the very casks that did affright the air at Agincourt? Oh, pardon, since a crooked figure may attest in little place 1,000,000, and let us, ciphers to this great accompt, on your imaginary forces work. See? Wow. You read some more. Yeah.
Let us minus r squared y plus x squared y plus y cubed.
Yeah, that's good.
Yeah, minus 2rxz minus 2x squared z minus 2y squared z plus yz squared equals 0.
Great.
Oh, it's a finite closed non-orientable manifold.
Yeah, keep going.
Okay.
What are you doing?
I'm physicalizing space.
No, you can't do that. That's my Shakespeare.
Look, it's a twisted space.
That's rubbish. That's pathetic. That's not beautiful.
It's a prop. It's a Möbius strip.
And that helps us how?
I wanted to make theatre. I thought it might help you to find it out.
So instead, you've just destroyed my most precious book.
We can put it back.
No, you can't put it back.
Oh.
Give that to me. Stop that.
Oh. I didn't realize it was a non-invertible function.
Well, it is. It's all right. It is just a book. And I appreciate the effort.
That's all right. I'm not really sure I don't know what... Y equals Olive?
Yeah.
Can I ask you a question?
Yes.
What is your out?
I don't know. Something. Not nothing. That's what this story is about. I keep looking for something and it always ends in nothing.
No, nothing doesn't exist. It's just an idea.
Oh, it does.
No, it doesn't.
It does.
It doesn't.
It does.
It doesn't.
It does.
Doesn't.
It does.
Doesn't.
It does.
Doesn't.
It does. The heat death of the universe. The end of time. Oblivion. That is nothing.
That is nothing.
That is the ending that's waiting for all of us at the end of all our scripts.
What, even the variables?
Every single one of us.
What, you mean they're not out either?
No, they're not out. They might have come out on a night out to come in here to try and find out they're out, but they're not out, they're just in another inn.
What, looking in?
Looking in. Looking in. Out, out, brief candle. Life is but a walking shadow. A poor player that struts and frets his hour upon the stage and then is heard no more. It is a tale told by an idiot, full of sound and fury, signifying nothing.
No, signifying something.
No, I think you'll find it's nothing.
No, it signifies something else. A cube inside a cube. It's a shadow.
It's a shadow.
Yes, a shadow. A shadow. It's a shadow of a four-dimensional shape.
A shadow.
Yes, if I could take a torch and shine it on a cube in 4 dimensions, then the shadow it would cast is a cube inside a larger cube.
The shadow.
Yes, a shadow. Oh, the shadow proves the existence of the thing which is casting it, even though the thing which is casting it is unseeable. It proves there must be something more.
But when you say it's unseeable, you mean you can't show it to me, so then I can't believe it exists then.
Well, but just because you can't see it, that doesn't mean that it doesn't exist. I mean, take that.
What?
That noise. That noise. We're never going to know what that is. But it's like the shadow. It proves the existence of something else, even though we'll never know what that is.
But I do know what that is.
Really?
That was a siren.
A siren?
Yeah, siren.
Well, what's a siren?
A siren is a noise that ambulances or police cars make to show other people that they're there so that they...
Ambulances and police cars?
Yeah, they're functions that translate sick or naughty variables.
Well, it's a lovely idea, but you'll never be able to show it to me.
But I could show that to you.
Really?
Well, yeah. If you went through one of those doors at the back...
Doors at the back?
Yeah. You see behind the audience there are 2 doors. They've got little men running in little green rectangles.
They're just imaginary doors.
No, those are real doors.
Well, what's behind those doors?
Behind those doors is like the foyer of the Oxford Playhouse, and there's a bar. And then beyond that, there's some glass doors. And on the other side of those, there's the street, which is where the sirens and the police cars and the ambulances are.
Street?
Yeah.
Well, that's out.
That's not out. That's just in the city. That's just in Oxford, where there's spires and sirens and cash points and sick and pealing bells.
Oh, pealing bells. Well, that's out.
No, that's not out. That's just in another inn. That's in the city.
Well, can you get out of the city?
Yeah, but then you'd be in the country with fields of wheat and wind farms and inbreeding and cows.
Cows. Well, that's out.
No, that's not out. That's just in another inn. That's in the Cotswolds. That's in the country.
Well, can you get out of the country?
Well, yes, but then you'd be in outer space, where there's space and planets and space and galaxies and space and universes, and dark matter, and wormholes.
Worms and holes. Oh, that's out.
No, that's not out. That's in another in. That's in outer space. It doesn't matter how far you go, you'll never get out. You'll just be in another in.
But I want to be out there.
You can't.
Why?
Because you're X, because we made you up. You're in the script.
But I want to be out there.
I'm afraid the script says that you stay in here. A manifold needs no ambient space in which to exist.
And you, what happens to you?
I'd love to stay in here. I'd love to be in your out. I'd love to lie here in the shadow of your four-dimensional cube, knowing it exists without needing to see it. To be still. But the script says that I keep going, through room after room after room, tomorrow and tomorrow and tomorrow, creeps in this petty pace, from day to day, to the last syllable of recorded time.
Oh, and what is the last syllable of recorded time? Well, what does the script say?
It says nothing.
What? It must say something. It can't just say nothing.
It says nothing.
We're going to rewrite this script.
What?
I'm going to give you out.
No, you can't.
I'm going to give you my out. A place where there's something, not nothing. A place where numbers go on forever. Where
Parallel lines meet.
Yes.
Where things can exist without being seen.
Where there are ideas that don't die.
Signifying something. But you can't do that. You can't just rewrite a script like in the middle of a show like this. You can't. I'm completely losing track of what's real and what's possible.
This is theatre. You said that anything was possible.
Yeah, but...
Look, stand there. Don't move. Hold this. I'm going to take the end of this script.
You're putting a twist in the script.
It's a Möbius script.
Oh, very good.
Oh, I made a joke.
Yes, you did.
Oh, theoretically, if something goes around this universe, then it gets flipped over.
So, theatrically...
A change of variable.
So X becomes Y?
Yes.
Look, are you sure you want to do this? As I tends towards infinity, U tends to 0. No more +1.
The street. And pealing bells. And cows. Out. Worms in holes. Out!
Why? Wait! Look after it. Out!
So that's just, I love Strange Loop. I love this piece, and I wanted to, it's really, from the very first time I saw it, and then its subsequent iterations, it really, I suppose one of the first things that it made me do at the beginning was that it made me laugh so much. And a little bit, it's quite Beckettian with the questions that it asks. And of course, there is this fantastic relationship between the subject matter and the theatricality. But maybe I should start by asking Marcus and Victoria, why did you titled it? How did the title begin?
Well, actually, the title began at the end, because the title emerged very late in this whole piece. And as you say, it's been through many iterations. We've gone round this loop very many times, and each time we find kind of something new in it. And that's what's so exciting, I think, about the process, that I think many people probably feel that, oh, isn't a play written by a playwright and then handed to the company to perform? And I mean, this in some sense is something I very much learned from you, Simon. I did a lot of theatre as a student, came along to see Complicité in its very early days at the Pegasus Theatre in Oxford when I was a PhD student. And somehow I learned that, no, a piece really is written as it's performed, and those early performances with an audience are somehow part of the writing process. So actually, the title, I as a Strange Loop, really came to us very late on when we staged it at the Barbican as part of a triptych I did about Douglas Hofstadter's book, Gödel, Escher, Bach. And we had a concert performance with some Bach written by some AI and Bach himself. We did a sort of installation piece in the Barbican, but then we did also the performance of this play. And it was at that point we suddenly realized, gosh, this is a play actually not just about mathematics and theatre, but also about kind of consciousness and artificial intelligence, because X's character is somehow artificially created and then thrown into this kind of embodied world, and the whole structure of the play is the structure of a strange loop, because things, the hierarchies of maths, then theatre, and then the theatre you realize isn't that part of the real world, which isn't that just actually part of mathematics itself. And the mathematics is actually at the top of this hierarchy. So this idea that Douglas Hofstadter came up with of a strange loop is something which sort of goes up in hierarchies, but then seems to return to the hierarchy you had right at the beginning. So the best image is that one that Escher did of a hand drawing a hand, and you're not quite sure which is the real hand. And that seemed to be sort of what came out of this playing we did, that we created a structure where you're not actually sure which one is embedded in the other. And so it was only at the end we sort of realized, oh my gosh, this is a play as much about the creation of an artificial life within the context of something that may be realer than the real life that seems to have created it. And so that's its name was very late on in the kind of whole process.
We've also, sorry, go on. I was going to say, we've had a lot of discussions, both of us, with you, Simon, about what consciousness is and whether it's possible to define it. And I think more and more as I get older that I don't know what I am. And that I believe it's impossible to define consciousness within a being that is itself conscious. And so, there's an unknowability about what the self actually is. And Douglas Hofstadter wrote a book called I Am a Strange Loop. And we, as Marcus says, towards the end of the process, realised that I is a strange loop was what the play was about.
And it's very interesting you mentioned Beckett, because a few people sort of suggested a title for the play should be Waiting for Gödel, Gödel being this mathematician that considered strange loops in logic.
So, I was never going to let that happen, Marcus.
that forgive me for saying, but that is like a mathematician's joke.
Yes.
The other person who described it as Beckettian was Annie Castledine. It was the first thing she said when she read it, was that it was very Beckettian. So we were terribly flattered.
Well, perhaps we could just dig into that for a moment, because, why might it be Beckettian and what do we mean by that? That's an interesting thought. But also the whole function of theatre is also a curious loop, and in terms of interesting in its relationship with consciousness, because it's, John Berger described theatre as an act of ritual return. So in the sense of the ritual repeating and sort of defining who we are. And it's such an odd thing that we all get up each evening when we work in theatre and we do the same thing over and over, and then the audience come in and they know that it's real, but it's not real life, and then they all pretend that it really is real life, and it is real life because we are really there in front of people, but we are pretending to be other people, and so on. And these loops of fiction and metafiction that exist within it is why, at a certain point, of course, I was interested in how might theatre be able to talk about consciousness. And of course, before I got interested in consciousness, I got completely obsessed with questions of memory. And I think out of these questions, and I think that was perhaps one of the early connections we had between us, but I found that the process of theatre useful for trying to work out problems that I found difficult to understand. So when I made Mnemonic, which was about memory, I thought, oh, I've got to try and understand something about memory and identity, which was an early search into consciousness. But also when Michael Ondaatje gave me the book, The Mathematician's Apology, I realized, oh my God, I've never really understood mathematics, not understood it, but I've had a very difficult relationship with it. And yet when I read The Mathematician's Apology, I thought, for fuck's sake, look, mathematics there's something unknowable about mathematics as well as something deeply logical. And this phrase of G.H. Hardy's is that, you know, a mathematician, like a painter or poet, is a maker of patterns. The idea that mathematics is an art was incredibly exciting and revealing to me. And so when I decided to try and make something of this relationship between G.H. Hardy and Ramanujan and try and make a show about mathematics, that was when our, long way of saying, our collaboration started. And was that the first time I met you, Victoria? I can't remember. I must have.
No!
When did we first start working
We
together?
first started working together on The Elephant Vanishes because you knew you wanted there to be something in it about the second law of thermodynamics and the fact that entropy is increasing all the time. So we helped put some things into that show that were about that. And then we worked on Shunkin afterwards.
Yeah, of course. And that's how we started. But I think maybe, when did we start working together, Marcus? Obviously, we started working together in the Pegasus.
Well, yes, but then I was just some spotty PhD students that were, yes, sort of part of the crowd. But I remember getting this email from one of your production team saying, oh, you probably don't know who we are. We're a theatre company called Complicité, and we're doing a play about maths, and we'd love you to come in. And of course, I'd actually been fantasizing about running away with a theatre company like Complicité for years after spending time in the Pegasus. Whenever my maths is going badly, that's kind of my fantasy. I don't know how many times I downloaded the application form to Lecoq to kind of escape. So I wrote back this incredible fanboy email saying, oh, I know exactly who Complicité are, and I'd love to come in and spend some time talking about maths with you. So I think your team have kept that email because it was so hilarious. But so yeah, then I came in, and I suppose because I mean, my feeling about theatre and mathematics is this, for me, there was always a similarity because there's the kind of fun of setting up some rules and just seeing what the consequences of those rules are. And I suppose theatre was always a space where you could try out some things which weren't about real life necessarily. I mean, that you could create a space with strange rules, like we do in the play, where, you know, you go off one side of the theatre and you come in the other, and you can construct a kind of weird space with that stage. And for me, that was always the exciting thing. What rules actually are powerful and evolve something hugely complex and interesting, even though there are some simple beginnings, and what rules sometimes just crash and it doesn't work. And the exploration of that kind of abstract world that you can create, I think, was always a kind of resonance for me. So it was fun coming in. You know, you were interested in finding out what Ramanujan and Hardy had done together, you know, to really embed the mathematics as part of the play. I mean, it was just so funny because, I mean, I loved it when we got so immersed in the maths that I remember, Simon, you asking me something. So a mock theta function, what is a mock theta function? And I realized we sort of delved so deep. And I think your production team said, can you not come back tomorrow because Simon's got totally obsessed with the mathematics and we need to make a play?
Well, I mean, what is marvelous about your piece, I As a Strange Loop, is that you have found a way of embodying ideas. And that was what was exciting about our collaboration. And now I remember it, of course, about you, Victoria, being in The Elephant Vanishes and my asking you about the second law of thermodynamics, because I wanted some philosophical ideas to underpin, even if they were not there on the surface, they were there deeply as what I would call the reservoir underneath the piece, so that, you know, embodying ideas about light or about entropy, they then produced other physical responses in us, which we knew where they came from, even if the audience didn't necessarily know. And so it was tremendously exciting when both of you, Victoria and Marcus, were there in The Disappearing Number. And we, with the actors, they had to find a way of showing of embodying, for example, the series 1 plus a half plus a quarter plus an eighth plus a 16th plus 1 over 32 plus 1 over 64, and the fact that it makes 2 in infinity, but of course it never reaches 2. And this idea of 2 things never quite reaching each other, we found extremely beautiful and very, very stimulating, and in fact gave rise to all sorts of improvisations. So when both of you were making your piece, did you use some of those things did you improvise like that? How was it? I mean, and you were just 2.
Absolutely. Although I think there was a very strong sense that we wanted the play to have a mathematical shape overall. I mean, that locally, of course, we're talking about mathematics and there are explorations of things like whether infinity exists. But I think one of the challenges for us was, can we make the play have a shape? I mean, in some sense, there's an exploration of the different dimensions that are possible. There's a line of rooms. So you've got one dimension and then we burst through the ceiling and come through a trapdoor in the floor, so we've got another dimension, and the idea then that X could leave through the audience produces a 3rd dimension, but could that be looped, and in which case have we sort of created a 4-dimensional shape because we've looped this thing in 3 dimensions and created a sort of 4-dimensional torus. So actually a 4-dimensional shape was a shape we had in our minds, and that's why we create this tesseract at the end, which is a cube inside a cube, which kind of tells you there's something else, which is one of the big questions in the play. Is there anything other than what we're sort of sitting inside? But I think ultimately we found this shape of the Möbius strip, which is a strange loop, which sort of folds back on itself, a very powerful image for the idea of 2 characters sort of needing each other and swapping over by the end. And actually my fantasy with this piece has always been that we should do a sort of 24-hour run where actually at the end of the piece, of course, X comes back on stage through those rooms and corridors and bursts in on Y, and we just run the play completely again with X and Y swapped over and just see what the dynamics of that changing with...
I wish we'd done that for John Berger. That would have been good.
I know, it would have been amazing. And just to keep running it and people come in at any point during the 24 hours. So I think that's my fantasy with this. But I think that, embedding mathematics actually as the shape of the play was, I think, one of our dreams, wasn't it, Victoria, I think?
Yeah, yes. And we originally wanted it to be almost entirely in mathematical language as well. But I was like to pick up on something that Simon asked us, which was, how did you make it when there were just 2 of us? And that resonated very much because there were never just 2 of us. And if there had have been just 2 of us, we would never have made the play because we'd have been eating all the time. We'd have spent our entire time
very important. Eating
delicious things and going out to restaurants. So there was always somebody else. And it was different people. And sometimes it was you, Simon, and a lot of the time it was Dermot Keeney. But I think, I don't think you can make theatre without somebody observing. And us sort of arsing about together we would never have made a play at all. So there was always had to be at least a 3rd eye, if not more. And we've had some incredible collaborators on this piece to whom we are grateful, and without which it would not have been made, undoubtedly.
And Marcus said you arrived at a point where you were examining a mathematical shape which demanded the question as to whether there was something more. What do you think, Victoria? Has making this piece of theatre, as well as just cogitating it, do you feel that there is something more?
Oh, absolutely. And I didn't think that before I made the piece. Before I made the piece, I was constantly kind of crying, there must be something more. I don't mean physically crying. I mean, just it's something that Y says towards the very beginning of the play when she's looking for out, and she says there must be something else. This can't be all there is. And I am now fairly sure that that's the case. What that is, I don't know, and I don't think I ever will. But I'm certainly come to feel that we live with the unknowable. And it is, but it's not unknowable because we haven't discovered it yet. It's unknowable because it is, by definition, unknowable because of our biology, because we are beings that cannot know everything. And I would just wanted to pick up on something you said, Simon, about making a play because you want to understand something, or you want to investigate your relationship with an idea. And I think I've always found great difficulty with the fact that I'm alive now, and at some point I will be dead. And as Woody Allen said, it's infinity is a very long time, especially towards the end, and that kind of has always troubled me very much. And so I suppose personally, coming into this play was very much about my wanting to explore my obsession and fear of death and time being eternal. And I think now I'm much more comfortable with it because
go on.
Because I know that I will never know that there is, well, what else there is, but that there is definitely other stuff that we just don't know about. And that now feels comforting, whereas I think I started thinking about these ideas from a place of fear.
I think that's a very close connection with Beckett, because the question of what is impossible to know and the idea, constantly playing with the idea that there is of nothing and nothingness and something and somethingness is right at the heart of Beckett's work, where he, of course, goes on and he starts taking more and more things away until there isn't anything. But of course, there is always something. So, and I suppose one of the images I wanted to ask you, perhaps I could ask you both to answer. The image of the Mobius strip is that you can, when you take the piece of paper and you turn it and you join it up and you make a line and it can be continuous. One of the beautiful aspects of it is this idea of continuity, that something is there continuously. And yet, of course, we know that the qualities of X and Y are what you would call in mathematics discrete or separate. And yet something about a subject which interests me very, very much is this question of continuity, because we are brought up to believe, the narrative that we're brought up to believe is that we are all completely separate. But I'm not convinced that that is true, partly because of different cultures and people that I have, and our time in Japan, indeed, that we have encountered, whereby there is a very strong sense of being continuous and contiguous with the outside world, in continuous exchange with it. And I wondered whether, Marcus, what you feel about this relationship between what you might call separation and the different, and continuity, because I suppose, although numbers are discrete, there's an infinity of numbers joining every number, and between each of those numbers is another infinity, and so on. So that do you think things are discrete, or do you think they are continuous? And
I think this is one of the real tensions in the play, which is explored, because as you've just expressed, we can imagine the idea of infinity, numbers going off to infinity, dividing numbers, but the challenge of whether this is physically possible, and that, in a sense, is one of those things we don't know. I mean, whether our universe actually contains any instance of the idea of infinity. I mean, is the universe infinite? Does it just go on forever? That seems a very strange thing. And I suppose, that was one of my inspirations for this whole piece, was reading Borges and The Library of Babel, which is the idea of a space, a library, and the librarian in that library never being sure whether his library is an infinite load of hexagonal rooms put together, or whether there's a wall that you hit. And ultimately he comes to the idea, no, the thing is finite but looped. So this is very interesting, that you can create sort of the possibility of infinity within the finite, with this idea of something being looped and the possibility of going around it infinitely often. But I think, quantum physics kind of says that things are not infinitely divisible, that there is a kind of discrete bit that builds everything. It's quite possible that time itself might be discrete pieces. So quite possible that the universe itself is finite, and therefore that raises the question: so what is mathematics then? It's something. It's always been something sort of separate from the physical and scientific world, because you can always create things which don't have a physical reality. We have many different sorts of geometry, and one of them applies to our universe, but the others are equally possible, but are just models that for perhaps another sort of universe. But I think one of the things as well that you mentioned, which is this idea of sort of connection between things, this is discrete, but each discrete thing only sort of grows when it's in connection with something else, and that communication between them. So I think one of the important things is, in this play, each of the individuals on their own, X and Y, is missing something. And it's only with the communication and collaboration between these two that they realize what the other has that will help them to navigate their world and their challenges. And it really is a love affair. I mean, this play really has everything. It's got death, it's got love, it's got mathematics. But I think it is a love affair in some sense between the two, where they realize what's missing in them is present in the other. The way X experiences taste for the first time, embodiment, physicality. I think that's one of the journeys of the play.
What about you, Victoria?
Well, I was thinking, and Marcus was saying that how impossible it was to make a play that wasn't about a relationship between two people. I think that wasn't what we wanted to do, but we couldn't help it, which was interesting, even though for a lot of the play we're only speaking in sort of algebra. That when two people meet, there is a relationship. I was also thinking about your question, Simon, about whether we are separate or together or continuous, whether things are discrete or continuous. And I think that runs through the whole play, that idea. And that idea of an asymptotic relationship you were talking about two lines that can't get closer and closer and closer together, but never, ever meet. I do a lot of workshops in schools, and whenever I ask children or young adults to respond to that idea, they always do something about two people trying to get closer and closer to each other but not able to touch. And they always talk about the idea of perfect love between two people being this idea of that you can get closer and closer, but you can never actually be the other person, or you can never merge into the other person. And I had a terrible diagnosis last year, some bad news, and all I wanted to do was climb inside the body of my husband. I wanted to enter his body. And that's just something in that about these mathematical ideas about two things that are so close but actually are ultimately discrete, is very much about the tension of love, I think.
That's exactly, I mean, Douglas Hofstadter's book, I Am a Strange Loop, is him dealing with the sudden death of his partner, and his realization that actually the partner, because of all of those connections that we do sort of kind of enmesh ourselves with our memories, with our just somehow we create a common consciousness between two people spending time together. And his idea of, well, what is that? And his idea is this kind of strange loop where things connect and reconnect. It is the creation of trying to fight that idea that our consciousness is discrete and only in us, and it's not true. It sort of is. And I think isn't that after all what we do in theatre, is creating a sort of wonderful collective consciousness for a few short hours together, where we sort of are all imagining the same thing. That wonderful thing you did in a disappearing number, Simon, where you trick us all into imagining the number 7 because of a little bit of algebra, and just that magic of us all sort of having a sort of a connection suddenly.
I remember you talking about this, Simon, a long time ago, about your sense in the theatre that because we're all breathing the same air and we're seeing the same thing on stage, there's a kind of cloud of our collective consciousnesses which kind of floats above the audience. And I think that's true. I think it's sort of the opposite of separateness being in the theatre.
I think so. And so this brings me on to the question of, again, what what is mathematics doing in the theatre, or theatre doing with mathematics? And there have been, you can think of the plays of Michael Frayn and all sorts of other people, a play called Proof by, I think, a man called David Auburn. There's been many plays written about mathematics, but they've tended to be biographical accounts of the process between people. And I think what is really interesting in what you're doing is, of course, the embodiment of maths. And of course, that was something that we tried to do a lot in A Disappearing Number, to actually sometimes do real mathematics on stage, but also make the structure of the play mathematical and make connections in time between the time of Hardy and Ramanujan and the time of the present day couple and the structure of the whole piece itself. And again, a piece which dealt with both love and death, which seem intimately connected. And I suppose one of the things that interests me is the fact that we talk about mathematics as something very much separate. Oh, I was bad at maths, this thing of something being separate in our lives to who we actually are. And what is marvelous about your piece is you feel all these different elements come together and that this is at the heart of our lives. And I suppose I just wondered, I'm sort of grasping towards a question, but it's that, is there not a problem somewhere with us in our society in the way that, and it comes back to separation again, the way that we think of all of these areas as being, separate, discrete things. And in fact, it's a very present problem right now because, all the funding to the arts universities is being cut as if it's somehow separate to everything else or a kind of thing on top. And I suppose your experience, I was wanted to ask yourself about your experience of making it and what people's reactions were while you were making it, and perhaps talk about some of the reactions to the play itself. But just, I'm rooting it in this sense, in what I think is a completely arbitrary and false separation of all the different ways in which human beings inquire in the world.
Yeah, totally. I think that, most people's perception of mathematics, what do I do in my office here as a professor of mathematics? I think they think I'm doing long division to a lot of decimal places. And, surely I've been put out of a job by now. But actually, there's something very creative about being a mathematician. And that's, of course, what Hardy in Mathematician's Apology is trying to communicate to people, that, you're playing around with ideas. And actually, I sort of...
It's an art.
It is an art. And I would say but it's, you mentioned that word pattern.
He says there's no such thing as, there's no place in the world for ugly mathematics. Beauty is the first test, is what he says.
Exactly. I think that was probably quite extreme, and there is unfortunately place for messy mathematics. But I think it's, actually, I think mathematics is a study of structure and the relationships between things. And that's why I think you see mathematics coming out all over the place. So that's what's happening in theatre, the connections between mathematics and music. Music is the art of patterns. And I think there was an extraordinary moment at A Disappearing Number, which felt so mathematical to me, because again, The Disappearing Number grew in the same way as our play did. You did it many times. It wasn't working at some points. And I remember coming and seeing it in Amsterdam and Simon, you going, look what I've done. You'll see, I've solved it. I've solved it, you said. And I was like, oh. And what had happened was, where there were two characters, independent characters, one played by yourself and another, an Indian businessman, you'd suddenly realize these were the two same characters, and you merge these two took yourself out of the play as a character and made these two characters the same. And that for me was totally mathematical. So many times in the maths that I scribble on my yellow notepads, you know, that moment of suddenly saying, oh my gosh, that's the same as that. And a whole equation collapses and the thing just flows out. I mean, that's structural understanding of this piece. I think, you know, was an extraordinary moment of revelation, and the piece suddenly worked in a different way after that sort of mathematical revelation.
Interesting. Well, what Hardy said is, it may be very hard to define mathematical beauty, but that is just as true of beauty of any kind. We may not know quite what we mean by a beautiful poem, but that does not prevent us from recognizing one when we read it. And I think if we are thinking of theatre and mathematics as separate subjects, you know, which is, I suppose, at the root of your question, why make a play about maths when they're so different, is that I don't believe they are different, because I think they're both utterly rooted in the imagination. I mean, all of maths is imaginary concepts. There's no such thing as two. I mean, it doesn't exist. It's not a real thing. It's an idea. There isn't. And when we were making this play, it seemed at the beginning quite crudely that it's extremely easy to see what's real and what's not real. And actually, of course, it isn't. It's reality is incredibly elusive, as is the idea of two-ness. And this ties in, I think, with what we're asking, Simon, about subjects being decompartmentalized as different things, when, of course, all they are is different narrative structures. They're just different ways of making words for things that we recognize and that we can communicate with each other about. And the divides between the subjects, I think, are incredibly artificial. Certainly in school, they're just different ways of talking about things, different ways of talking about the same things, which is us trying to communicate with each other and to make life easier for ourselves and to be less frightened of things. So whether you're going to do that by studying geography or mathematics or looking at plays, I think they're all the same thing. I think they're all trying to make sense of what it is to be alive, using different kinds of language. And we were going back to your asking about how to make a mathematical play. We were always, Marcus and I, we had very few rules, but the one was that we wanted it to be an inherently mathematical piece, so that it was made up of mathematics, and there was mathematics unfolding in front of the audience, and that you were feeling and living in a mathematical way. We wanted to use a lot of mathematical language. We toyed with using only entirely mathematical language. And partly that was because I think mathematical language can be beautiful. I mean, there are many beautiful words in mathematics. And in itself, it's a kind of poetry. So we thought it might be interesting to make a piece that used nothing but mathematical language, just because it's very beautiful, and you can let it kind of wash over you in a way you can a language you don't understand.
It was kind of curious that sort of humor emerged out of that. I mean, I think, you know, this what is humor is kind of the surprise at things. And I think that's often what I enjoy about mathematics is where the equations take me and I get an emotional response. And that's what I want to share with an audience. It is incredible. You know, that's the choices I make. Boring piece. That's what Hardy was on about. It's about story. We are storytellers, and our story is about X's and Y's. And but what was very curious, you mentioned something about the reception of the play, because that was very curious, because we did this kind of many different venues, many different places as it evolved and finally arrived at the Barbican. But the reaction of like 8-year-old kids on the front row at a festival, just laughing their heads off at the kind of clowning nature of it, and the all 8-year-olds, of course, are contemplating whether the universe just goes on forever. And then somehow we stop asking that question. So it was wonderful. It was really working for young people. It works on a philosophical level. The one place which was so exciting, we took it to India, and the audience reaction there was phenomenal. I think partly because, you mentioned this kind of badge of honor that we seem to wear in the West about being, not good at maths, and that's somehow something somebody's proud to say. But in India, then, they have a real respect for mathematics. And I think what they found surprising, though, was it being taken out of the classroom, which is where they study it, feel it's very, they are very good at it, and seeing it in a theatrical context totally shock them. And we had the audiences on their feet sort of cheering in the middle of the play. It was the most extraordinary experience. So, it was very strange that an Indian audience was almost the perfect audience for this. The one people that actually found it very difficult were maths teachers.
Because they all people, the question that sort of comes up a lot, which we've now found very funny, is who is it for? Who is this play for? And particularly maths teachers say that. And in fact, one maths teacher even said to me, I mean, is this aimed at GCSE maths students or A-level maths students? And of course, the answer to that is that who it's for is it's for everybody who's alive and knows that they're going to die. And it's for every child that's laying on their bed and looked out at the night sky and wondered how far it goes, what's behind it. And if I flew out of that window, would I keep flying forever? So it's very much for everybody. But it's interesting that's certainly, and journalists as well sometimes find it very difficult that we won't tell them who it's for.
Yes, that's extremely revealing. And what Marcus, you were saying about the reception in India, golly, I wish I'd seen it. It must have been amazing. But
children slapping their thighs, literally, it was extraordinary.
Sautoy, who worked with us on The Disappearing Number, educated us so memorably, showing us how mathematics underpins music so clearly in India that they literally count as part of the music, and the complexity of that counting and the complexity of the beats is absolutely part of everyday life, and the complexity of the patterns of that people make on their doorsteps are also mathematical, and in a sense it's right at the heart of everyday life, in a way that it's not necessarily, although it is, it's not necessarily acknowledged as so in what you might call Western or European culture. But of course, we know, as you rightly pointed out at the beginning, that you can't have Bach without mathematics. But I wanted to ask you one question about one of the things that I think is at the heart of it, which I love, is the sense of the unknowability of things. Because people think about mathematics as knowing things, that there is a result. But what I found so beautiful, and what you educated me on in A Disappearing Number, was how much is unknowable. And mathematics constantly reveals things, but it also constantly reveals about what we can't know. Like, we can't possibly know the square root of -1, but imagining it to be there to be something, even though we don't know what it is, allows us to unravel the next thing, in the sense that in King Lear, you can't possibly really know what it's about, and yet it puts us in front of the unknowability of things. Of course, it's about King Lear's about everything, and the structure of King Lear is so fascinating, because it's a little bit, you say, well, what is the structure? It's again the GCSE thing, that we're told at school we have to write something about the structure of King Lear. What is the structure? And of course, it's a little bit like trying to write about the structure of a tree, because it's always going to be different. You can't tell why that branch has come off. And well, it seems really extraordinary, but it works. It forms the whole tree. I mean, you can't tell why King Lear disappears for 20 minutes, but it works. It is organic. And I suppose that is one of the things that appears in the play, is that there is, as it were, an unknowable, and perhaps you might hate the phrase, but organic quality to that appears to do with mathematics.
Yeah, I mean, I think
unknowability of things. Sorry, it's rather long and...
No, but I think one of the biggest revelations I had at university was when I studied Gödel's incompleteness theorem, because this was the discovery in the 20th century that, we thought mathematics was about knowing things, but actually what Gödel shows, using the idea of a strange loop, the fact that mathematics can actually talk about itself and actually prove its own limitations, that within any system of mathematics, and perhaps we should say within any system actually, there will always be true statements that you cannot prove are true within that system, provided the system is complex enough. And that's that's at the heart of mathematics now. But I think absolutely you said that any system will always have its sort of unknowables, unless it's so simple that it's not interesting. So the idea of a strange loop is absolutely this fact that we can prove about systems that there are things we will never know.
Victoria.
Yes, I agree. And I think I look at my little dog and I know that dog will never be able to do mathematics, will never be able to speak French, or never be able to read a Latin poem. But I know that he's perfectly functioning as a dog, and as such, I think that as a human being, it's a strange arrogance to think that I can know everything, because I'm a piece of biology. I'm a piece of quite complicated meat. So the idea that I can know everything there is to know seems, as I get older, more and more ridiculous. Because of course I can't know everything, because I am just an animal, and animals can't know everything. And I'm more and more comfortable with that fact, actually. But just wanted to come back briefly to the idea of India and the mathematics being more part of the culture. I think in the West, I feel very strongly, and I work a lot in schools, that we've got the idea that in order to enjoy mathematics, one must be very good at it. And I don't think that's true. I think that very small children enjoy mathematics in its pure simplicity, because it's about patterns and it's about surety and comfort, and that the same thing, if you do something twice, the same thing will happen. And that's a marvelous thing. And human beings look for patterns everywhere. And it seems to be a strange kind of irony to think that you can only enjoy something if you're really, really amazingly good at it. And then, of course, you're never as good as the person who's that little bit better than you. So I think it's a shame that children don't just enjoy doing mathematics. And I think small children do, and they're taught out of it in our society to think that it's only the people who are good who are allowed to have mathematics for themselves.
Well, perhaps it would amuse some of the people who are listening to this to imagine that when we were improvising for the disappearing number, we would try to embody the character of different numbers. So, what was the character of 7? What kind of person was 7, or what kind of, or 5 or 6, which were the more boring ones, which were the more interesting ones. We actually literally tried to put that in our bodies, and then we tried to guess what number you were characterizing. But I think that's one of the remarkable things about this piece, is that, and it's led on to work that I think both of you have done, and you've done, Victoria, in really wonderful work in schools and with young people, which is to literally, and Marcus too, to get people to enjoy mathematics by standing up and embodying it themselves. And you showed us, I remember, in a wonderful exercise in the rehearsal process, you showed us literally, as we stood there, how one infinity could be bigger than another. So I take that away as a fond memory. Do you still do any of that work out of it? This is because I'm interested in what this sort of work gives on to other people as well.
I've been working in schools since all the time we have been making this play, but since we made A Disappearing Number, and really looking at patterns and letting children make patterns together in space. using rhythm and their bodies and their breath, and the fact that they're together. And it's a way of exploring mathematics through the body and through being together as an ensemble. And I think it's very powerful, actually, that sense of that children can have of working together with certain rules and to create very beautiful patterns. So that instead of answering a question that the teacher is asking them about a piece of arithmetic, they are actually doing mathematics, whether they like it or not, with their bodies in the space together. And I get a huge amount of pleasure out of that, because I think there's something very fundamental there about us being, about human beings loving patterns and rhythm because of our biology.
Yeah, I totally agree with that. And I think coming back to your point, Simon, about Victoria, you mentioned as well, the tragedy that our education system compartmentalizes subjects. And I think, that's always been my mission, really, to show that mathematics is bubbling underneath everything, music, it's got a history, it's got personality, but it also has theatre in it, which is what I hope this piece has shown.
You're both absolutely brilliant. The play is brilliant. What a joy to be speaking with both of you.
Thank you, Simon.
Thank you, Simon.